Hello participants, I welcome all the participants to this 3-day workshop on blockchain and Bitcoin fundamentals, and I welcome you to the day 2 session on blockchain and Bitcoin fundamentals. So I hope you have enjoyed day 1 session on blockchain and Bitcoin fundamentals, wherein our mentor has dealt with basics of blockchain. So I hope you have understood the first day session. So type yes in the chat box if you can hear my voice clearly and if you can see the screen. Okay, okay, thank you. So let us wait for 2 to 3 minutes for the other participants to join. Meanwhile, you can share this YouTube link with your friends and also with your colleagues. And today our session starts exactly at 6 p.m. So try to join before 6:05 p.m. Be in the session and tell your friends to join by 6:05 p.m. today. Meanwhile, if you have any queries regarding yesterday's session, right, you can just keep posting in the chat box. So once our mentor will be online, right, he will be answering your queries. Our sincere thanks to the branding partners for this 3-day workshop. So our associate partners for this 3-day workshop are School of Computers IPS Academy, Mallareddy Engineering College, Sri Manakula Vinayagar Engineering College, Vijnana Bharati Institute of Technology, Nanda Engineering College. So our sincere thanks to all our associate partners for this 3-day workshop and also to the participants who have joined for day 2 session on blockchain and Bitcoin fundamentals. So if you are facing any problems with the chat with the voice, right, you can just let me know in the chat box. And also if you are facing some difficulties with the on viewing the screen, you can just let me know in the chat box. And do share this YouTube link with your friends and also with the colleagues so that they'll not miss this session. And make sure and tell them to join by 6:05 p.m. It's exactly 6:05 p.m. the session starts. So make sure to be in the session by 6:05 p.m. Tell them to make sure to be in the session by 6:05 p.m. So yes, I think everything is perfect now. So yes. So from here, Kaushik will take over. Yes, Kaushik.
Yes, Sushant. Can you hear my voice?
Yes, Kaushik, your voice is clear.
Is it clear? Are there any disturbances?
No disturbances, man. Everything is
Okay,
fine.
right. So, can you able to see my screen?
Yes, Kaushik.
Oh. So, hello all. Hope all of you are doing well. So, I'm Kaushik from Skill to High. I'm mentor for this 3-day session on introduction to blockchain technology. So, we have this. This is our day 2 session, right? Yesterday we have discussed about fundamentals of blockchain and how the system works, right? So we have seen a concept like SHA-256 hash function, how hash function works. We have seen how that hash function is used to form a immutable ledger, and we have seen how distributed P2P networks work. We have seen what is mining, what challenge miners are trying to solve for adding nodes, right? So we have seen different types of consensus protocols. Anyone having doubt in the previous session, you can ask in the chat box. So today's session is all related to the previous session. If you didn't understand the exact definitions, or do you have any queries in previous session, so let me know. So you will have trouble in understanding the concept of today's session if you have any doubts in the previous session. So please let me know in the comment box if you have any doubts in previous session. So we have discussed about Byzantine fault tolerance, right? We have discussed about how mining works. Anyone having doubt in that concepts, I will give you a quick summary. So please let me know in the chat box. So I will wait for 2 minutes and I will start today's session in 2 minutes. So if you have any queries, please post in the comments. If you have trouble, any trouble in hearing my voice, right? You can let me know. So I think all of you got a basic overview of how blockchain technology works, right? How distributed networks work, how they agree upon things. There will be no central authority guiding the network, right? So they should rely on themselves, but the system should be unique, right? So we have talked about how they come to consensus, right? So if you are clear with those concepts, we can continue with our session today. So please let me know if you have any doubts. Yeah, Praveen Patel is asking that please explain me what is blockchain. So Praveen, blockchain is nothing but a list of growing transactions. So they are connected using a cryptographic puzzle, right? So you can think it of as a digital ledger, which is distributed across distributed network, right? So no central authority maintains it. So it is all distributed and open source. So anyone can join the net and they can follow the protocol and they can exchange information in the net. So I hope you got a basic idea. If you didn't get it, you can see our previous session. You can watch the video on YouTube. So subscribe to our YouTube channel, so you will get notified when there are live sessions or on any other technology site. So I request please subscribe to our YouTube channel. So everything is fine, right? I think there are no any doubts. So shall I start the session? So Praveen Patel is asking in which areas blockchain has used. Praveen, there are so many areas, right? Mainly financial sector and supply chain sector, health sector. There are so many sectors that this technology disrupted, right? So mainly these sectors you can take. These are the biggest sectors that this technology has been using, right? Mainly you can see decentralized finance now booming, right? If you're following the news, the decentralized finance is booming. So Uga Surya is also asking, tell me short life. So as I had told, blockchain is nothing but a bunch of transaction records. The blocks are linked with cryptographic puzzle. So as I have told in the yesterday's session, you can think it as a ledger book. In ledger, what you do, you write all your transactions, right? Like you have a book of ledger, you write all the transactions. But this is a digital ledger. Digital ledger means it does not there in one database, right? It does not have a centralized authority maintained it. So it is a distributed network. So everyone maintains the ledger. So there is no central authority maintaining it. So there are no intermediaries between us. So we can follow the protocol and we can exchange value like cryptocurrencies. In Bitcoin blockchain, you can exchange Bitcoin, right? It is a currency. It has some value, right? So we can eliminate the intermediaries and we can use those protocols. Okay. So let's start our today's session. So this is the agenda of our today's session. So you can see we'll talk about mostly Bitcoin blockchain. So why Bitcoin blockchain means it is a first application created on blockchain, right? So it is a famous one. It is most powerful one. So for beginners or to understand the blockchain technology, it is very important to know about Bitcoin blockchain. So if you directly go and learn other blockchains like Ethereum, you can understand, but you should have, if you want to become a blockchain developer or if somebody asks, if you don't know about Bitcoin means there is, they think that you don't know anything about blockchain, right? So it gives a base idea of how this technology works, right? So it's all began with that Bitcoin blockchain, right? So it's important to learn about Bitcoin. So we will see about what is Bitcoin and exactly what cryptocurrencies are. We will talk about Bitcoin monetary policy. Like banks have their monetary policies, Bitcoin also have their monetary policy. So we will understand the mining difficulty that we have talked in previous session, right? So I told you that why they are using so much computation power. I will tell in this session, right? So I will tell why that is so hard to find that puzzle and why they are using that much computation power to find a valid nonce, a valid hash, right? So we will talk about exactly why that is so much difficult, and we will talk about mining pools, what there are mining pools, right? We will talk about yesterday I have talked about nonce, right? We will talk about nonce range, right? How certain the nonce range is, how much is their nonce range, right? It's not infinite, right? It's a finite number, right? What is the range of that? What parameters it affect when the nonce range is filled, right? So we will talk about that. We will talk about how miners pick transactions in network, right? So there will be a bunch of transactions, right? Which transactions they prefer to pick, right? So like that, we will see pictorial representations of that. And at last, we will talk about the 51% attack. It's the famous attack, right? If you are talking about blockchain or Bitcoin with your friends or colleagues, you may heard that about in movies, right? You may heard in movies, right? 51% attack like that. So we will see exactly what is 51% attack in block. So let's start the session. So we will see exactly what is Bitcoin, right? So people get confused about coming to cryptocurrencies actually. So what are cryptocurrencies actually? They get confused. They are confused about what are tokens and what are cryptocurrencies. Cryptocurrencies are different from tokens, right? They get totally confused about the terminology in the crypto space, right? So someone say they are tokens. There are so many tokens, and someone say they are not tokens. They are cryptocurrencies. Is there a difference between tokens and cryptocurrency? We will see. In crypto space, there are mainly three layers. We have a technology layer, we have a protocol layer, and we have a token layer. So these three layers are main part of this crypto space. So what is the technology here? We have seen right in the yesterday session, and we have seen the technology is blockchain technology. So they store records in blocks and they attach to the appending chain with sharded-bits algorithm, right? So they form a ledger, right? So we have seen about blockchain in the previous session. So in crypto space, the technology they use is blockchain technology. So what is protocol? So in layer 2, we get all these cryptocurrencies like Bitcoin, Ripple, Ethereum. You should understand that Bitcoin is not just a currency. It's not just a digital currency. Under the hood, it is the protocol, right, that makes this work as a currency. So why you use our Indian dollar as a Indian rupee as a currency, right? So government approves, right? So that's why you use that currency. Why you use Bitcoin means as a currency means, so then the participants in the network approve that it is a currency, it has some value. So it's nothing but a protocol that is guided that Bitcoin is a currency, right? So a protocol is nothing but a set of rules that how participants over a network communicate with each other. So for example, we have TCP/IP or HTTP protocol, right? So they allow participants to communicate within each other, right? So if you have IP protocol, internet protocol, that uh, that connects all of us through internet. So it is IP protocol, right? If you have HTTP hypertext transfer protocol, that allows our browsers to display websites correctly, right? So Bitcoin is no different. It is a protocol, a set of rules on how participants of the Bitcoin network will communicate with each other and agree on things. For example, the protocol dictates how they should come to a consensus that we talked in our previous session. So the protocol also dictates how public keys and signatures should be used for authentication of the user. And there are lots of other things that protocol dictates. There are other protocols in the crypto space like Ethereum and Ripple and Litecoin. There are so many, right? So mainly we are focusing on Bitcoin. So you got to understand, right? Bitcoin is nothing but a protocol. It has some set of rules. Everyone in the network follow those rules and exchange information, right? So here they can exchange value also. That's a extra credibility we are getting by using blockchain technology. So not only information, we can exchange value also. The important thing you should notice, these protocols have their own coin. If you take Bitcoin
Yes, participants. Yes, yes, yes. I think there might be some connectivity issues. Just Kaushik will be added in soon. Just be patient for 2 minutes. Just be patient for 2 minutes. He'll be back. Just wait for 2 minutes. Yes, he got disconnected. Actually, he'll be back. Yes, Kaushik, we can hear you now.
Okay, Sushant. You
Yes.
hear me, right? You can see my
Yes, fine.
screen.
We'll continue. Yes, yes.
Okay.
He got disconnected here. Yes, fine.
Yeah, give me 1 second, guys.
Okay, okay, fine. You can continue.
Yeah. So you got a basic understanding of what protocol is, right? So what Bitcoin is nothing but a protocol. It has some set of rules. Everyone in the network follow that rules, right? So coming to layer 3, it is a token layer. When you heard companies releasing an ICO, which is called an initial coin offering. So what is that ICO means? Actually, they are offering tokens, right? If you see in stock market, a company goes public, right? So they release IPO, which is called as initial public offering. So in crypto space also, there is a concept called ICO. Rather than shares, we release coins to the public, so everyone can buy those coins. If a company has an upright future, right? So they can buy those coins, and they can trade those coins. Exactly, you compare with the coins with stock market. So give me 1 second. Okay, you got a basic understanding of what is token, right? So you can compare a token with, in traditional finance, you can compare with a share of a company, right? So companies release ICO, called as initial coin offering. Nothing but they release tokens in the network, so anyone can buy those tokens with them. So the difference between coins and tokens is coins. Sushant, can you hear me? Hello. Can anyone hear me? Please comment in the chat. I am audible. Am I audible?
Yes,
Comment in
Kaushik,
the
you are
chat.
audible. Yes.
Okay, okay. So Praveen is explain me what is token. Yeah, I will explain. So the difference between coins and tokens is coins rely on protocol layer. So tokens rely on smart contracts, which are built on 10 protocols. So smart contracts are nothing but a piece of code running in the blockchain. So we are not going in depth of what smart contracts are. Simply, you remember, it's a code running in a blockchain. That is a smart contract. The simple explanation of smart contract. Right? So, for example, Ethereum is most popular protocol for creating smart contract. There are other protocols like Neo, from which you can create smart contracts, right? So tokens are formed using those smart contracts, right? So Bitcoin doesn't have any tokens within the network. It doesn't have any tokens. So Ethereum has so many tokens, like you can see, Link, Synthetics, and there are so many. There are tokens in Ethereum because Ethereum gives that extra credibility of smart contracts in this network. So it has ability. It has the ability to run code in the blockchain, right? So Bitcoin and Ripple doesn't have that ability. So Bitcoin has ability called Bitcoin has some coding language like codes, which we don't discuss in this session. But if you want to, like, you if you are interested, you can go and check out in the so you can see about Bitcoin offers. But it is very limited. It is not a Turing completed language. So Bitcoin doesn't have any tokens. So tokens come in layer 3. So the blockchain which gives a specialty of smart contracts, they have tokens. So Ripple and Bitcoin doesn't have. So token is nothing. Yeah. You can compare token with current share of a company, right? So in traditional finance, like we see, so we have a market also. So if there is a project or a company built using Ethereum blockchain, so they want some funding, right? So what they do means, so in traditional finance, a company goes public by applying IPO, right? So they go to public and they sell it and they get funding like that, right? So exact scenario is applied in crypto space, but they do in cryptocurrencies. So they create their own token by using smart contract. So they give it to a public sale in the network. So anyone can buy those tokens if they like the idea behind the project or the idea behind the company. So token and coin are both different. So I want to point that the important point to notice, coin is native currency of the blockchain. Like for Bitcoin, there is BIT. For Ethereum, there is ETH. It is a native currency which is used to give incentive for the miners. So Ethereum doesn't give incentive for miners in tokens. It give in Ether, right? So it is a native currency that is called cryptocurrency. Token is different. Token relies upon smart contracts. So Bitcoin and Ethereum, Ripple doesn't have tokens. So Ethereum has a suite of smart contracts, so you can create tokens. So I hope you got an idea of what is token and what is cryptocurrency. So please let me know in the comment box if you understood the concept. So I got it. So I think you got an idea of what these three layers in crypto space, right? That technology is blockchain technology. So the protocol defines which blockchain how to work. You got tokens layer, right? Only smart contracts available blockchains can create tokens. So Bitcoin and Ripple doesn't have tokens because they don't have Turing completeness, any programming which any code running in that blockchain. So they don't have tokens. So let's see. Let's go to these websites. These are two famous websites uh, to monitor cryptocurrency prices and what tokens are there in the market, right? So you can go to coinmarketcap.com. So I will share my screen once. So you can find the link in the chat box. I think you can share that. You can search in Google coinmarketcap.com. So Sushant, are you able to see my screen?
Yes, Kaushik, it is visible. It will be better if you zoom in a bit.
Yes. So you can see
Yes, it is.
there is bit. Oh, it has become so large. So you can see different cryptocurrencies like you have number one Bitcoin, right? So Ethereum, Tether, XRP, Bitcoin Cash. There are a lot of cryptocurrencies in the space. You can go and you can study about these currencies here. So if you go to Ethereum, you will get all the market statistics. What is the current price of Ethereum? So what is the market cap of Ethereum? What is the market capital of the Ethereum? You can see the graph of Ethereum. You can see 20%, 24% change. You can see the circulating supply is there, right? So you can see all the statistics in this website. So you can see currently it has market cap of 41 billion, right? $41 billion. So it have $12 billion of 24-hour volume. It has 112 million circulating supply rate. You can see the graphs, and if you want to know about any cryptocurrency or any token, you simply come into CoinMarketCap, or there is another website called CoinGecko. So you can search in your browser. So you can study about this. So you can see about Ethereum. What is Ethereum? They gave a nice overview of how Ethereum is. So you can see the current price of Ethereum. So who are the founders of Ethereum? You can get the whole overview of that project or uh, cryptocurrencies, right? If you want to know anything about, if you saw a new project is coming and you want to contribute to that project, or you want to know about what that project is, you simply come into the coinmarketcap.com. You go into CoinGecko, or you simply search about the company or coin. You can see the statistics, and you can see about. You can go to their official website here, right? There are announcements page. They gave a chart, and you can go and see source code of their code. They are all open source, right? So you can go and check all the statistics. You can go and see all these statistics in this web. So you can play around with this website in your free time. So these two websites are most popular explorer of cryptocurrency. You can see there are so many cryptocurrencies. There are tons of there are thousands, right? More than 1,000 cryptocurrencies and tokens. Not only cryptocurrencies. Mainly there are so many tokens built on Ethereum, on Io, or Tron, like that. So there are so many cryptocurrencies and tokens you can find. Right? So you can play around with this website. Sushant, can you hear me?
Yes, we can hear you. We can hear you.
Are you able to see my screen?
Yes, Kaushik. You're not sharing your screen, I see. Yes, you are sharing this
Okay,
Chrome browser.
Okay, one.
Kaushik, can you hear me?
Yes, Sushant. I have
Yes,
some
yes.
network issue.
Okay,
I
okay, no.
want.
Yes, no problem, no problem. You can just continue.
So can you see my screen?
Yes, 1 second. Yes, yes, you can see it.
Okay. So you can go around and play with this website. Play means you can get a whole overview of what cryptocurrencies and tokens. You can go and search in this website. So we will see who invented Bitcoin. So Bitcoin was invented in 2008 by a person of people who were operating under the name of Satoshi Nakamoto. So nobody knows who exactly Satoshi Nakamoto is. We don't know that he is a one person or a group of people maintaining under a group name called Satoshi Nakamoto. So nevertheless, a white paper is published under the name of Satoshi Nakamoto. So we all assume that Satoshi Nakamoto is a person who invented Bitcoin, right? So then in 2009, Bitcoin system was implemented, and then where the revolution of blockchain came into space, right? So it opened a large doors in distributed networks and decentralized finance industries, supply chain industries, right? So you can search about Satoshi Nakamoto, right? we don't know exactly who is that person. Nobody knows it. So we assume that he is a man. Bitcoin is invented by Satoshi Nakamoto. If anyone asks who invented Bitcoin, it is under the name of Satoshi Nakamoto. We don't know exactly who that is, or who is she, his or her. If they are a group of persons, we don't know about. So Bitcoin is invented by Satoshi. So what is Bitcoin all about? So Bitcoin is about that blockchain technology from theory moving into practice, right? So they use that technology to create a Bitcoin application, right? So they created this network using the technology. So you can see a network of people here, right? That means computers can transact with each other using this technology. Now, all of a sudden, there are no intermediates between these transactions. Like there are no banks between them, right? So they don't need any permission to transact with each other, right? So if you are an Indian and you want to transfer money to US, you need to have the banks need to have some contact, right? Between them. So those are two different countries, and you're transacting from one country to another country. Right? So you will have a lot of tax, right? So in blockchain network, in bitcoins, there is no such intermediaries operating the system. So it is free and open source. Anyone can join the network and transact the information. So the important thing to note here is they can still not trust each other and they can transfer information. So whether I don't know, I'm transacting to a address. A Bitcoin client has, you can see here, right? There is a two address and 0.1 BTC. It is from Coinbase BTC wallet from. So Coinbase is a Bitcoin wallet. You can transfer Bitcoins with that wallet. So he represents with an address. So we will talk about Bitcoin addresses and private keys and public keys in day 3 session. You will get a whole overview. Simply think about address is like my ID. So think about it is like my name. So I can generate so many addresses. So I don't know the receiving address who is receiving, but I will do transaction, right? Because I trust the system behind it. I trust the blockchain technology, right? So I can transact exchange value in a trustless environment also. So that is great, right? So until now, before Bitcoin, there is no such system like in the world. There is no such system eliminating intermediaries and transacting or exchanging value in a trustless environment, right? So here you can see there are so many miners in the world connected in the network. And wait, I will open my pointer. So you can see my pointer, right? Okay, here is a Bitcoin client. He has this address, so it is a hexadecimal number. It has 20 bytes. We will see addresses in day 3 session when we talk about public keys and things. So he is sending 0.1 Bitcoin to this address from this Coinbase BTC wallet. So here is the receiving Bitcoin client. You can see he gets 0.09 Bitcoin. So the difference here is 0.01 Bitcoin, right? So it is a transaction fee that they are paying to the miners to execute this transaction. You got my point, right? So yesterday we talked about miners get some transaction fee from users who are transacting, right? So they give some. You can simply think as it as of tax. You pay tax to bank, right? So like that, you pay tax to Bitcoin miner who is mining the transactions for you. So they are contributing to the network, right? So you pay tax to the Bitcoin miner in form of transaction fee. So here the transaction fee is 0.01 Bitcoin. This is an example. Transaction fee can be set by the user. There is no limit. He can set whatever transaction he wants, or he can take off the transaction limit. It's not a mandatory field. You can take off the transaction field and you can transact. But we will talk about why we should introduce transaction fee for the miner to mine your transaction. Right? So we will see in future why it is so important to make a transaction. So you got a basic understanding of what is Bitcoin, right? So if yes, you can comment in the chat. So Kevin is asking, where does Satoshi Nakamoto belong to? So we don't know exactly. No one knows in the world who is that Satoshi Nakamoto. In 2008, simply a white paper pop up, and there is a white paper called Bitcoin P2P electronic cash system. So I will give a white paper link to you. So you can read that white paper and you can get the idea. Nobody knows who is Satoshi Nakamoto, as I told you. So they mentioned the name in the white paper. So everyone tells that Bitcoin is invented by Satoshi Nakamoto. So in Bitcoin ecosystem, these four players play a major role. So Bitcoin client is nothing but you or me who is trying to transact in Bitcoin network. So you can see Bitcoin miner, as I have told before, right? There are large miners than individual miners. I have shown some peaks, right? Yesterday's session. There are so many CPUs and GPUs. There is a large mining farm, like industrial mining farm. Those are called large miners. So if I am mining in my house with my one CPU rig, means I am a normal Bitcoin miner. So the difference between minor and large miner, why I differentiated between them. Right? So these have a lot of hashing power, while I have low hashing. So we will see concept of mining pools in the coming slides, in the coming topics. So mining pool plays a major role in Bitcoin ecosystem. So you need to keep this in mind. These four plays a major role: Bitcoin client, Bitcoin miners, and peaks. So I want to just give an overview what are the players in the network, right? So I prepared this side. So you can create Bitcoin white paper here. So you can go to bitcoin.org/bitcoin.pdf. So the link will be shared by Sushant in the description. So you, in your free time, you go to the page and you try to read that. It is not so much complicated. There is no complex math in that. So there are 12 sections explaining the whole technology, how mining works, how mining difficulty works. If you have free time, you go on read. I highly motivate you to go on read if you want to get a clear understanding of how things work in this Bitcoin, right? So it is called a P2P electronic cash system. So you can go on read that white paper in your free time. So I highly suggest you read at least the headings and at least the theory. If you don't understand anything in that, so you simply try to understand what you understand. So you will get a basic idea. You are listening this session, right? So you will get an idea by read. You will get more idea by reading that paper. So I highly motivate you to read that white paper. So you can go. You can see Sushant. I think Sushant shared the link in the description, right? So you can go around in free time. You can check about the white paper. So I hope all of you got an overview of Bitcoin, right? So if you have any doubts, please let me know. I'm going to. We will discuss another topic if there are no doubts. So if you have any doubt, please comment in the chat box. Okay. So we will see a concept called Bitcoin monetary policy. So unlike central banks or any reserve bank, any bank, they have their own monetary policy, right? So Bitcoin also have their own monetary policy. It's all maintained by the algorithm. So it is already predicted. So someone asked, the Satoshi Nakamoto was Japanese, sir. So we don't know exactly, but there are rumors and there are some predictions that he is Japanese, but we don't know exactly who is. So there is no correct proof that Satoshi Nakamoto is, but there are some rumors. Yeah. So unlike traditional banks, Bitcoin has its own monetary policy. We will see what is that monetary policy and how Bitcoin maintains that monetary policy. So in Bitcoin monetary policy, mainly it consists of two parts. So it has a Bitcoin halving. It has a concept called principle called block frequency. So we will see in halving. The meaning of halving is that number of bitcoins released into the system is half every 4 years. So it's not exactly 4 years. It's for every 210,000 blocks. So you can see this picture, right? So in 2009, it is called a block era 1, where a miner get 50 Bitcoin incentive for mining the. So he get a reward of 50 Bitcoin. So after 4 years, you can see 2012, exactly not 4 years. It's an average calculation. So after exactly 210,000 blocks, there is a reward era called 2, where the generated bitcoins are half. As I told in the yesterday session, the bitcoins come into the network, come into the supply by mining process only. There is no other way you can get free bitcoin, right? Only the bitcoins are generated by mining. Gold comes by mining, right? So exactly bitcoin comes from mining. So here after 210,000, the block reward of Bitcoin reduced by 2. You can see they are getting only 25 Bitcoin. They are getting only 25 Bitcoin now into the after 420,000 blocks. Again, there is a halving, third halving, second halving, which is called reward era 3. The Bitcoin again, the generated Bitcoins are halved again. So the block reward for the miner is 12.5 Bitcoin in 2016 to 2020. Recently, in May 2020, there is the third halving of Bitcoin is done successfully. This is all controlled by the algorithm predefined only, so no one can change that algorithm. So we have seen that, right? In previous session, no one can change anything in code. So today the block reward of Bitcoin is 6.25 Bitcoin. So you can go around and you can search about in Wikipedia what is the supply of Bitcoin, and the total supply of Bitcoin is 21 million only. There is no minting or there is no creating any Bitcoins more than 21 million. So the total number of Bitcoins in the circulation supply is right now 18 million, I think. I will show you exactly how many Bitcoins are there right now. So these are generated by the process of mining. You got a understand of halving principle, right? So the block reward for miners is half for every 210,000. So why they are halving? Why they need to half, right? So in economics, you can see a concept called inflation, right? So inflation is nothing but you buy a cup of tea 4 years ago and it is 4 rupees. You buy same cup of tea right now, it is 8 rupees. Let's think that way. So the price of the same tea is double, right? So why it is double means it is due to inflation. So there are so many circulating currencies coming on. Banks are printing so much currency. So the inflation rate is growing. So the same cup of tea is now 8 rupees. In 4 years, before 4 years, it is 4 rupees. So that is called inflation. So to reduce that inflation, this system is designed so that it will be a deflationary system. So what happens in Bitcoin means for every 210,000 blocks, the block reward halves, which makes that Bitcoin so much more valuable, right? So it is a deflationary token, deflationary currency, whereas our rupee or dollar is inflationary currency, right? Banks print whatever they want, how much they want, they can print that currency, right? So this is a deflationary system. So nobody controls it. It is already pre-algorithm, and in advance they wrote the code, right? Everyone can see that code, but no one can change that. It is in the blockchain, right? So no one can change. So you got understanding of what is inflation, why they are doing halving, right? So So there will be no inflation. So to make a deflationary system, they are reducing the block reward half, right? So this process continues until the block reward becomes zero. Then all the 21 million bitcoins will be mined, and uh, uh, you can think they will get some stable value like gold. But nevertheless, we don't want how much rate Bitcoin get, right? So we are talking about the technology bit. So I hope you all got an understanding of it. So let's see some charts here. So give me a second. See this chart, right? So Sushant, can you see my screen?
Yes, Kaushik, we can see it.
Okay. You can see there is a graph here, right? So this blue line is bitcoins. There are total number of bitcoins. This orange line is inflation line. So the inflation is decreasing. So in 2012, as we have seen, first halving is done, right? For that, 10 million bitcoins already came into supply. In 2016, second halving done, the block reward again, 15 million bitcoins came into the circulating supply. So in 2020, another third halving came and 18.3 million bitcoins are there in the current one. So like this way, for every 4 years, for every 210,000 blocks, the block reward comes down, and the amount of circulating supply of Bitcoin reduces. So this process continues and goes on until it becomes zero, right? So you can see a formula here. I think it is not visible, but I'm telling inflation equal to Coinbase into blocks per year by existing coins. If you don't understand the formula, it's no need of understanding that. That I have mentioned it. So you can see this graph, right? So why I'm showing this is how I want to show a graphical representation of what I have talked about. So you can go around with this link. Play. I'm sharing my screen. Okay. Here is another graph, right? So give me 1 second. Give me 1 second. So Prashant, can you see my screen?
Yes, Kaushik, it is fine now.
Okay, you can zoom my screen.
Yes, I've done it.
So here is another graph. So yeah, we have to get a question right. So miners are doing such computational. They are using so much computational power to find a nonce, and they are spending a lot of money in gas, right? So why they are spending this? They are getting a block reward, right? So if the block reward decreases, the miner doesn't show interest in future mining, right? So he want to quit, right? So how to do that? If all the miners quit means there is nothing in the network, right? So to maintain, the miners should come and actually participate in the mining process so that all the transactions are executed, right? So what the algorithm defines is, so if the block reward decreases, here you can see the red line is block reward, right? So the yellow line is here is transaction. As I have told, um, You can give transaction fee. You can specify this much amount for minor transaction fee when you're transacting, when you are generating a transaction. Right? So you can set that when while time goes on. Here is the time, right? Total fees per month. So while time goes on, the block reward gets halved and reward goes down, right? So what makes miner to mine the block is it is a transaction. So you can see this blue line, right? This is a total mining incentive that the miner wants. It's the average mining incentive that a miner gets for contributing to the network. So if the block reward goes down, the transaction fees goes up. So we pay more transaction fee for the miner to execute our transaction. So these two balances the incentive for the miner, and the miner, if first halving done, he is getting only 25 Bitcoin per block, right? Before he is getting 50 Bitcoin per block. So he want another 25 Bitcoin, right? Before he is getting, now he is not getting it. So how he will get is he collect that from transaction fees. So you pay more transaction fee for a transaction to get executed. If you didn't pay sufficient transaction fee, your transaction will wait in the pool. We will see what that pool is, memory pool in the next concepts. So simply now remember that transaction fee you should pay for the miner. So it is optional, but for execution you should pay for the miner. So we will see in the next concept why it is exactly necessary to pay the transaction. So I hope you got an understanding, right? So why miners don't leave the network means the incentive for the miners is balanced by transaction fee. So to maintain this deflationary system, they wrote this code in advance, right? So they wrote this code such that the miners don't leave the network and the network should crash, right? So if there are no one maintaining the network, no one, there can be a single monopoly, right? If the small miners and every miner leave the network without mining, they get less incentive. So a large miner, a big miner, a, a central authority can maintain the network, right? So there will be monopoly. To take out that monopoly, they introduce this transaction fee, which balances the incentive of the miner, and it gives extra credibility to the deflationary system by giving uniqueness. So what is blue line representing in the graph? So blue line is total mining incentive. So at first the blue line is about, let's imagine the blue line is 50 Bitcoin. At first starting of the network, the miner gets 50 Bitcoin, right? As we have seen here, 50 Bitcoin, right? So this you think this range is 50 BTC. So after some time, the Bitcoin, the incentive goes half, right? By halving, you can see here one step it goes half, right? So he is not getting this much reward, right? So how this reward is, this reward he will get that reward, right? Means he will get from transaction fees. The transaction fee increases when time goes on. So you got an understanding, right? The blue line is total mining incentive that a miner expecting from the network for him. Okay. So we will. You got a basic understanding of what is halving concept, right? If you have any doubts, please let me know in the chat box. Okay. I think there are no doubts. So the second concept here is block frequency. So what is block frequency means? It's how often the blocks come into the. It is how often that blocks come into the blockchain. So give me a second, guys. So Sushant, can you see my screen?
Yes, Kaushik, yes.
Okay. So I thought all of you got a understanding of what is talking. So let's go into another concept. Another concept in the Bitcoin monetary policy is block frequency. What is block frequency means? It's how often the blocks come into the system. So in Bitcoin blockchain, every 10 minutes there will be a new block mined. So in Ethereum, for every 15 seconds, a new block is created. In Ripple, like 3.5 seconds. Every 3.5 seconds, a new block is created. Uh, it's it is dependent on which blockchain they use, which network they are in. So, but in Bitcoin, it is 10 minutes to create a block. So we will see why we need 10 minutes to mine a block, right? So we have seen that mining process is so much. They should find a valid hash to mine that. So it takes 10 minutes for a Bitcoin miner to mine a block. So it's the average time. It's not exactly 10 minutes. So it is the average time. It can have to be 5 minutes or sometimes it may be 15 minutes. So averagely 10 minutes, but every 10 minutes a new block is mined in the Bitcoin block. So we will go to this Explorer and we will see it, right? So we will see some statistics. So you can go go to this blockchain.com/explorer. So you can see different stats in there. We will come. So we will frequently come to this website during the session. So I will share my screen. Okay, Sushant, can you see my screen?
Yes, yes.
Okay. So you can see this is a real-time explorer. You can see there are latest blocks, right? Currently, 36 minutes ago, a block is mined here. So these are a bunch of transactions. Remember, as I said, a block contains so many number of transactions, right? So a block limit in Bitcoin is, I think, 1 MB. So 1.2 MB right now. So a block contains 1.2 MB of transactions in that. It's not exact, I don't know, but it's 1.2 MB right now. They are trying to improve that. So they are trying to improve that uh, memory space between the blocks, right? So how many transactions should a block? The community is coming and trying to solve that issue. Why they are need exactly one MB block size, right? So you can see here there are so many latest blocks, right? So clicking on view all block. So these are the latestly mined blocks, right? So 38 minutes ago a block is mined, and 53 minutes ago a block is mined. 1 hour before there is 7 minutes gap, right? So here only hours are there. So basically the average time for a block to mine is 10 minutes. So it's not exactly, but average time to mine a block is 10 minutes. So in network, a new block comes every 10 minutes, averagely. So you can go around with this blockchain.com website, and you go to Explorer and you try to monitor the real transactions what are happening. So you get a good understanding of how things are going. Like you can see latest transactions. You can see so much stats here. You can see charts. Be visiting this website quite a lot in this session. So you can go to blockchain.com/explorer. Okay, let's go to our presentation. Give me one second. So I hope all of you got an understanding of Bitcoin monetary policy, right? If you have any doubts in that, please let me know in the chat. So if you don't have any doubts, we will continue on to the next concept. If you have any doubts, please let me know. So I hope there are no doubts on Bitcoin. I think you got an understanding of what is halving and what is block breaking. So one important point to keep in mind is there is no single authority maintaining this monetary policy. It's all pre-coded in the software, so no one can change that because it is in a decentralized network function. Right? We have seen in the previous session what happens if we change that. No one can change it. So okay, I got a clear. So now let's dive into the another concept called mining difficulty. So I have told in the previous session, I will tell you in today's session why it is so difficult to mine a block. So we will go through that concept, and we will see why exactly miner should contribute that much computational power to mine a block. So you can see this chart from previous session, right? I have given these diagrams in previous session also. So the miners, what they do is they randomly they brute force the nonce, and the network gives a target, right? Like we have talked about 4 leading zeros before in the previous session. So they need to get a hash between that level of target. So they brute force the nonce value, and they get different hashes, and if the one who gets the valid hash first will be the winner of that round, and he gets the chance to add a block to the blockchain. So we have seen why he won't add malicious transactions in before, right? So there is a consensus protocol, right? So everyone verifies that block. So and if that is a valid block, he gets the incentive. He gets the block reward per trip. So he gets some profit by doing that. So you got this is a quick overview of mining process. So let's do some calculations. So while I'm preparing this presentation, this is one of the block's current hash. So it has 20 leading zeros within the hash. So it is a 64 byte hash, right? So it is a 256-bit hash. It has 20 leading zeros with it. So as we have seen, we have taken an example of currently four leading zeros the target is right. So when I'm preparing this presentation, it is 20 leading zeros. So we do some estimations, right? The total possible 64-digit hexadecimal numbers are. So how can you tell 16 into 16 into 16 into so on up to 64, right? So it is 16 to 64, which is exactly not, which is equal to 10 power 77 around. So we have 20 leading zeros, right? What it takes is it eliminates 16 power 22 values in the total number of hexadecimal games. So it will be 16 power 64 minus 20. You can see here, right? Which is around 10 power 52 hashes. So there are nearly 10 power 52 hashes, valid hashes. So in 10 power 77 total number of hashes, a miner should pick a hash, a valid hash, and the valid hash size is 10 power 52. You can see 10 power 52 is a large number, but when comparing to 10 power 77, it is so small. It is very tiny. There are 20 zeros for the 10 power 77. So even though 10 power 52 is a large number, when compared to 10 power 77, it is a small number, right? So we calculate a probability of a randomly picked hash is a valid hash. So what is probability means? We get our favorable cases by total number of outcomes, total number of cases, right? So we do 9 into 10 power 52 by 10 power 77, which is exactly 9 into 10 power minus 25. You can see that probability is here, right? It has 0, 0, 0, 0. Almost it has 18 zeros here and 9 here. It's so ridiculous, right? Is so low, right? So the probability is so very tiny. This is a probability that a miner picks a nonce and he is getting a valid hash. So the probability of getting a valid hash in the space is 0.000 so on 9. So it is very tiny. So it is very hard to a miner to find a valid hash. So you can feel that feeling, right? So oh my god, this much probability. Statistically speaking, it is impossible to uh, find a block such that in less time, right? So they need so much computation power. So they brute force nonce so much so that they can get all the hacks, right? So it is hard. The important point to keep in mind is it is so hard to find a nonce, uh, find a valid hash in the total number of pool of hashes. So I think you got a clear view of calculations, right? If you have any doubt, please ask me in the chat box. So this is the probability that a randomly picked hash is a valid. So it is ridiculously low. It is 0.003. So if you have any doubts, please ask me in the chat box. Okay, I think there are no doubts. So why this probability means we will see. Let's go and calculate our mining difficulty. How we calculate mining difficulty with the mining difficulty is calculated by current target and max target. As we have seen, our current target is when I'm preparing this presentation, this is a one of the hashes, right? So with 20 leading zeros. The max target is here is this 8 leading zeros and FFF 00. So difficulty is adjusted every 2 to 16 blocks, right? I have discussed it previously, right? Every 2 weeks, the mining difficulty changes, the target changes. So if there are more number of miners adding into the network, so next time the difficulty rises because the demand of mining is high, right? So the target that the difficulty will be high. So the network adjusts within every 2016. So you should get it out. Why max target is 8 with the 8 leading zeros and FF, right? So in 64 byte hexadecimal number, the maximum value is FF so on 64 times, right? So why they took this as a max target is, so let's imagine if they have taken this largest number FFF so on 64 times as a maximum target. So what happens is when they release the network, so every nonce they pick is a valid nonce, right? So the target will be in top of the pool, right? So we should get a hash below the target, right? So the concept is we should get a hash below the target. So what happens here is the difficulty adjusts every 2 weeks, right? Before that 2 weeks, the miner can mine all 21 million bitcoins, right? So there is uh, nothing stopping him, right? So every nonce he picked, he get a valid nonce, right? So he can mine blocks within seconds. He can mine all the bitcoins within seconds, right? So that's why you can see here red line, right? So they gave some with a target with 8 leading zeros. So they declared max target is 8 leading zeros. So that initially they get some difficulty for them. So you can see this is our current target. So this is the max target. So what is difficulty means this space is there, right? Let me show my point. Yes, you can see my point. So this space you can see, right? Current target by max target is the difficulty. So this space is the current target. We should find a hash within this target space. This is a max target. So the difficulty is this space divided by this space. So that is the mining difficulty that we are talking about. How difficult for a miner to find a valid hash. We calculate mining difficulty such. So I hope you got an understanding of how mining difficulty is calculated, right? So let's go to some charts and see some statistics. So again, blockchain.com /chart difficulty. You can go to that website. So I'm sharing that screen. Give me a second. So you can see here This is a network difficulty chart. This is 1 year chart. You can see here November 3rd, 2019, the difficulty is the miners are doing 13.69 trillion hashes per second. So they are doing 13.69 trillion hashes per second. So that much is the difficulty. So you can see about this chart information. So the difficulty is a measure of how difficult it is to mine a Bitcoin block. So, or in more technical terms, to find a hash below a given target. So, as I have explained before, that is what it is here. You can see THS by terahashes per second. Yeah. The chart is in terahashes per second. Let me give a overview of all-time chart. When I go to all-time, you can see at the starting, the difficulty is so low, right? So, because there are so many less miners. So, for less miners, the difficulty will be low. So as network grows, there are so many miners, right? So the difficulty increases. While the miners increases, the difficulty increases, right? So to maintain stability, so the miners should get a correct challenge, right? So the difficulty doesn't changes every 2010. So in future, there are so many computation powers, right? So like quantum computer or something. So they can easily mine hashes, right? So for that purpose, the network difficulty also raises when not miners. The difficulty doesn't change about how many miners. The difficulty changes how much hash rate they are using. So if they are using more computational power means the network is getting more computation power to mine the block means the difficulty raises. So the network has less computation power for mining means the difficulty decreases. So I hope you got a basic understanding of what this difficulty is, how this difficulty is set is, current target frame max target. So we can go around and see this stat here in this website. So the website is blockchain.com. You go charts and explorer, you can play with that website and see real world stat. Let's go to our presentation. So these are some pictures I have taken for you to show how a mining farm looks like and how a mining rigs are look like. This is a big mining farm. This is an industrial mining farm. There are so many rigs, Bitcoin rigs and mining rigs. So there are so many Bitcoin rigs. So these are some of the miners working in mining farm. So they are fixing those circuit boards and they are cooling the system. They are cleaning the system. So I want you to show these pictures. So how a real world mining is like to get you a good understanding of how mining functions. So they actually live there. They live there and they maintain the mining farm. So this is their home. So I hope you all got an understanding of what is mining. So if you have any questions, please comment in the chat box. Okay, sir, could you please zoom the screen? Oh, sorry. Sushant, can you zoom the screen? Hello, Sushant.
Yes, Kaushik. Yes, sorry for that.
Okay, yeah. They are asking to zoom the screen.
Yes, I have done it, Kaushik. You can just continue.
Okay. So there are no. So someone Naveen is asking, is Bitcoin was legal in India? It is legal in India, but before Reserve Bank banned Bitcoin, but now it is legal in India. There is no, but there are some rumors, right? Bitcoin will be banned, cryptocurrencies in India, but there is no official notice for that. So why Bitcoin ban means actually the Bitcoin can't be banned by any government. So anyone can use that. They can't come and to stop using Bitcoin means they should stop internet, which is impossible. So why they are banning Bitcoin is, so they actually first banned mining in India. So because electricity is very problem in India, right? If you use all the electricity for mining purpose, that isn't that advantage for our country, right? So actually they banned mining, but you can use Bitcoin anywhere in the world. No one can stop you by using cryptocurrencies in anywhere in the world. I mean, you can use anywhere. So we will see the concept of mining pools. So we have seen miners and we have seen industrial. So now let's dive into the concept of mining pools. So let's say there are some miners in it. So we all know the process of mining, right? That all compete with each other to solve the cryptographic puzzle to get a reward. So we have seen previous pictures where we have seen tons of graphic cards and GPUs and mining rigs are there to mine a block, right? So let's say here these two nodes are industrial miners, as we have seen before. So in this case, how is that somebody can compete when I have a tiny laptop and or my Bitcoin rig in my home and they have a huge mining power in these industrial ones. So it's just unfair, right? I can't compete with them and get a valid hash before them, right? So it is ridiculous. There is no fair in the system, right? So uh, this is where concept of mining pools come. So even a small contributor should be worth in the network. So the network should not be taken by large big whales and big miners, right? So here comes the concept of mining pool, which solves that problem. You will see that. So what happens here is these miners, you can see this blue and red colors, right? These miners combine their caching power. They form a pool. So they combine their caching power to mine a block. So all of a sudden they have more power together, right? So uh, instead of doing solo mining in our house, if you connect it to some other miners and we put our go, let's say I connected with these 4 miners and we place our 4 rigs at a time. So it gives more hashing power than one rig, right? So simply that is a pool. So mining pool provides a service where the pool distributes the work among the miners in such a way that they are not doing double work. So what I meant is they don't do double work. So let's say I am finding valid hashes from 0 to 1,000. If another miner in the pool also did the same 0 to 1,000 nonsense, means there is no point in doing that, right? Sushant, can you hear me?
Yes, Kaushik, we can hear you.
Oh, okay. Give me a second. There is no point in doing double work, right? So that is very good, right? So because there is no point when 2 miners in a pool doing the same work and calculating exact number, right? So the pool distributes the cryptographic puzzle among the members. So anybody can join in the mining pools. There is no restriction. So they can even join in the industrial mining pools also. So they can come with and join with these large pools. Give me a second, guys. Okay, they can come and join in these large pools also. They can. There is no restriction in joining a mining pool. If there is a pool, you can go on. You can contribute your computation power by connecting to that pool, right? So I can join with the industrial miner. So these 4 nodes can join with this industrial miner also. So there is no such restriction to join. So why mining pools means? So every individual can contribute that. So what happens now? This one mining pool found a block and they got reward, right? So they fairly distributes the reward. How they distribute the reward means they distribute a reward based on the how much hashing power, how much competition you have contributed to the network. So if you on whole 100% of hash, can you see my screen, Tusha?
No, Kaushik, it is not visible. Can you reshare it?
Okay, I will do one thing. Now can you see? Can you see?
Yes, we can see it now.
Okay. So again, we go to blockchain.com/form. There are so many explorers here. You can go to the website and play around when you have free time. So this is a 4 days mining pool flash distribution graph. It is a pie chart. So you can see there is an unknown pool occupying this much space in hash rate distribution. There is a pool called F2 pool. There is a pool called pool in PooBoy, pool via BTC, btc.top, btc.com/pool. There are so many pools, right? So majorly the small ones they can show here. Majorly Bitcoin miners actually join a pool that gives good results for them instead of doing solo mining. So there are so many pools in here, right? So you can see unknown pool mined 138 blocks in 4 days. F2 pool bought 90 blocks in 4 days. Pool in mined 73 blocks. You can go on 30, right? So there is a hash rate distribution like this. So just I want to show the how mining pools, how much of a mining pool occupies the network. So there is no more than 25%. Right? This unknown pool occupies, I think, 22% like that. So there are no monopoly. Okay, that's for the presentation. Let me share. Okay, I think all of you got a basic understanding of mining pools, right? So if you have any doubt, so Naveen is asking the how many server farm and energy power is wasted in Bitcoin. So wasting means there is no such thing. Bitcoin mine is eco-friendly. Yeah, that's a disadvantage. I think it's not an eco-friendly, but mm, it it uses so much energy, right? So it is a disadvantage. It is a main disadvantage of this Bitcoin network. So there are other consensus algorithms rather than using uh, the Ethereum is moving to proof of stake, right? Where you don't need to use this much computational power to participate in it. So there are much more productive consensus algorithms coming into the place. So this is a major disadvantage of Bitcoin network. In some countries, in some Bitcoin farming, they use uh, whole New Zealand is using the same electricity as a one Bitcoin, right? So we need that much electricity to mine blocks. So, but there are so many developed algorithms, but it is just create algorithm, but we cannot change that consistently. So if you want to change that means all the network should be forked and we should change the, so we cannot change the code. So Bitcoin is not exactly eco-friendly, Bitcoin maintenance. So, but we are getting such a, when compared to gold, Bitcoin is good. Yes, indeed. Yes. They're saying like old people are buying, old young generation is buying. So for value purpose, it's so precious, right? You can see this technology how it's so powerful. Right? I think you got a basic understanding of how mining pools work, right? So uh, we let's go into our next concept called nonce range. So we know about the nonce field, which allows miners to participate in the cryptographic puzzle, right? So we have seen that in our previous sessions, and we had talked about nonce so many times, right? So miners change these nonce and find different hashes, and they want to find the hash. So someone is asking Bitcoin value in India. So its value is same all over the world. So I think currently it's 11,000, like 10,900. So it's not about the discussion is not about Bitcoin value on mining. It's about the technology behind it. It's about blockchain technology. So if you are interested in Bitcoin, you can go and you can write yourself. You can go some exchange and you can buy some. So, but the main thing to note is the technology behind is so important. It disrupted so many industries. Right? So it is good to know about that technology. So we have seen nonce before, right? So we have seen miners manipulate that nonce and they participate in cryptography. So, but there is a catch here. Uh, the nonce is not infinite, right? We cannot keep incrementing the nonce. It has some range, right? So it is a computer code, right? So it is a UINT 32-bit unsigned 32-bit integer. So the range of nonce is simply 0 to 4 billion. So yes, we got understood that nonce has some range, right? So why is it important to know that nonce have a range? So let me show you. So let's do some estimations here. We have seen these estimations before, right? Let me open my point. So we have seen these estimations before, right? We found the probability of that a randomly picked hash is valid is this much, 0.0. So now let's calculate nonce. We know that nonce has a range, right? 4 into 10 power 9, right? 2432. So that this means 4 into 10 power 9 different hashes are valid hashes. So these are the valid nonces. So probability. So let's find the probability that one of them will be valid. So what we do is we know the probability that a randomly picked hash is valid is this, right? So we multiply that with our total number of nonce range.
Due to some network issues, Kaushik got disconnected. He'll be back in a minute. Please be patient. Just in a minute, he'll be back. He'll be back in a minute. Please be patient. And as I have done yesterday, in the same way, I'll be pasting a feedback link in the chat box. So I'll be pasting the feedback link at exactly 7:50. So at 7:50, you can just start filling the feedback. I'll share the feedback form link in the chat box at exactly 7:50 p.m. So yes, Kaushik is back. Yes, Kaushik, you can start.
Okay. Sorry guys, there is some network. So we have done this estimations before, right? So the probability of randomly picked hash is valid. This we have calculated before, and we know that nonce has a range of 4 billion. Right? So let's find a probability that one of that nonce is a valid nonce. So what we do is we multiply that 4 billion to the probability that a randomly picked hash is valid. So we get this much probability. So it is still not enough, right? So it is still hard to find the non-valid nonce, right? So let's imagine a miner brute forces the nonce in that block. So he completed all 4 billion nonces. So, but he didn't get the valid hash. So what he could do, he could simply just wait, right? So we don't want that system, right? So we want the miner to do something, and we have so much computation, right? So we should give extra credibility for. So here comes a let's okay. Before that, let's say average miner does 100 million hashes per second. Average Bitcoin miner do per second, 100 million hashes. We have 4 billion hashes, right? Since the nonce is 4 billion, so we can get 4 billion. 4 billion by 100 million is 40 seconds. So it takes 40 seconds to brute force the whole nonce range. So after 40 seconds, what the miner should do? He should just simply sit if he doesn't get the valid hash. So there is a catch, right? So how this situation is tackled is there is a new field called timestamp. So we didn't see that this in previous session. So I am introducing a new field in that block called a timestamp. This is a Unix timestamp. So if you are a programmer, you know what is Unix timestamp. It is a number of seconds that have passed since 1st January 1970. So in computer world, we calculate time with Unix timestamp, right? So these are the number of seconds that have passed from 1st January 1970. So it has a timestamp. So let's say there is a 4 billion range nonce range. Right? The miner is there is a timer clock, right? See this timer. So let's say in 1 second the miner have brute forced this many nonces and he is finding the valid hash. So 1 second happened and this much nonces he found. Let's say what happens after 1 second happens is the timestamp changes, right? This 2 becomes 3. So the seconds in the timestamp change. So remember the avalanche that we have talked in the previous session, right? So a small data is changed in the block. So the hash of the block is completely changed, right? So now what happens is the miner again can reuse this nonce, right? So the data is changed. Now for every nonce we get a entirely different hash, right? So the miner can reuse this part. So he doesn't wait up 40 seconds if he completed all the nonce ranges. After 1 second, he can use that nonce range again to find it valid hash. So this timestamp field is used like this. All the timestamp field can be used which time Bitcoin block is mined, but this catch is resolved by timestamp. So I hope all of you got a basic understanding what I am saying. There is a limit. The important things to keep in mind is there is a limit for that. What happens if the limit reaches and the miner doesn't get a valid hash? So as I have told, 100 million per hashes, right? There are 4 billion hashes. 4 billion per 40 seconds, the miner can complete the whole nonce range. The average miner, not an industrial miner. An average miner can do 100 million hashes per second. So after 1 second, he gets the extra credibility to use that nonce again to find different hashes, so that the timestamp resolves that catch, the nonce range catch, right? I hope you got my point. So let's see some charts with state. Let me open this chart and share my screen. Ashkan, can you see my screen?
Yes.
Okay. So this is a hash rate chart. The 1 year hash rate chart. So this is hash rate per terahashes per second. This is the time. So if we keep all time, so the hash rate is increasing. So what is this graph is about, you can see it here. The estimated number of terahashes per second in the Bitcoin network is performing in last 24 hours. We have per 1 second, this many terahashes per second they can do means. So we have seen that a nonce has only 4 billion, right? Within fraction of seconds, they can complete the whole nonce range, and there is no, they should wait for another second to happen, and the timestamp should change, and they should use again that nonce range, right? So this is kind of fuzzy, right? So let's say in 0.1 millisecond the total nonce range is over, and another 99 milliseconds he should wait, right? So this doesn't give expected results, right? So waiting for 99 milliseconds in 1 millisecond is ridiculous. So they are maintaining so much computational power, right? So to solve this issue, what the network done, you will see, right? So timestamp changes for 1 second. For 1 second, they can reuse that, but you can see that, right? So per second, there are industrial miner can mine trillions of hashes per second, right? So it's a fraction of seconds for him to do the whole nonce range. So what they do in that time? So let's see. Let's go to our presentation and see. So now a concept I will introduce is how miners pick transactions. So the picking of transactions resolves this issue. I will show you later in slides. Let me open my pointer. Yes, you can see, right? So let's see the concept of how miner pick transactions in the network. So here is a block. So how does a miner pick transactions? That goes into this data field. So as I have told before, this data field is nothing but a bunch of transactions, right? So how does a miner pick these transactions? See. So the transactions come from something called a memory pool in the network. So every miner maintains a memory pool. Right? A memory pool is nothing but a large pool where pending transactions are. So in memory pool, we have all these. This is a memory pool. We have all these pending transactions. We have all transactions that are waiting to get confirmed and loaded into block. So every miner has a mempool where there are little transactions that are pending. So the miner will need to include some transactions into them. So for our sake, let's say miner should include a max of 5 transactions. So there are transactions signatures here, right? In mempool, you can see there is a. I am not showing the entire transaction in this picture. Fee here. You can see there are a bunch of transaction fee, right? So the fee is paid and specified by the user only. So there is no need of paying fee, but to execute you should pay fee. Now let's see why that is important. Right? So what does this miner do means? If you are a miner means what you will do? You will go and pick a large fee transaction, right? So that if the block, if you are a winner, you get that block means you are getting more profit. So exactly the miner do as it is. So he picks a in memory pool he sees, and he picks for our estimations. Let's say one block has 5 transactions. So he will pick a top 5 transactions. Sushant, is my screen? Can you expand my screen?
Yes, Kaushik, I did it. Yes.
Okay. So he takes a bunch of transactions, let's say 5 transactions. What we will do is he take the transactions which have high fee. You can see these are the 5 transactions which have high fee. So he will include that in the transactions. So now he brute force the nonce and try to find a valid hash. So what we will do is 1 second, 1 second is complete, and he got up to he used this much things, and what happens here is the timestamp changes, right? So he can reuse this nonce again. So remember the avalanche effect, the timestamp change, the data in the block change means the whole hash will be changed, right? So he can reuse this nonce to get some hash. So now what he will do is again he will continue from like this. What happens if so? Let's say we change to 6 and he can again use. So what happens if an industrial miner comes and if a large mining pool comes and which does terahashes per second, in less than 1 second he completes the whole nonce as we have discussed. So now what he will do? He should not wait this much time, right? It's a waste of time for him. So the electricity is waste, right? He can't turn off and on within 1 second to save that time, right? So what he will do? Simply he will change block configuration. So nothing but he will change the data in the blocks. So he will change the order of transactions. What he will do is uh, this is the least fee transaction before, right? 0.004 BTC. So he will take off that least fee transaction and he will include another least fee transaction. So he changed that configuration. Remember the Fibonacci effect? Now again the data in the block changed, right? So he can reuse this whole nonce again. So what happens? He changed the block configuration. So now he can you can see from half second to from 20 seconds like that. Now 50 seconds over. Again he completed the whole nonce. What again he will do? Simply change the block configuration again. So now he can include another transaction. He takes the less transaction fee transaction here. He includes second less transaction fee 0.002. Again, what he will do? He will start. So what happens now is the whole he pushes the nonce from here to here, and now 1 second completed. Right. So what happens? 1 second completed means the timestamp will change. So remember the Fibonacci effect. Now 1 second is completing. So they can he can reuse the whole nonce and he can reuse the whole transactions also. He can get that 0.004 transaction again and mine the block, right? Because the timestamp changed, right? So like this way, they don't waste their time. I remember one point, miners doesn't hand, they don't pick this transaction, then they keep into this data field. So it's all done by algorithm itself. So he can't do within seconds, like go and take from transactions memory pool and give to the data field, right? So this all will be done by the algorithm itself. So simply the miner runs the algorithm. So the algorithm chooses transactions from the memory pool. So why transaction fee is important means if you kept less transaction or zero transaction, no miner wants to mine your transactions to be getting to executed. I think all of you got a understanding. If you have any doubts, please ask me in the comment box. Meanwhile, read this Medium article to get an overview. If you don't want to listen video again, if you don't understand, you go and read this Medium article by Kirill Ermenko. This gives a overview of what I have told before. I will put this link in the chat box. Sushant put this link in the chat. Sushant, I have given link to you. You please paste that link in the chat. So I think you got a basic understanding of how things work in why it is so important to put your transaction fee, right? What is memory pool and all those stuff. Meanwhile, if you have any doubts in non-read, please ask in the comment. So you can read Sushant, please post that link in the chat box, right? So you can go through the chat box and you can read how things work. If you are a reading person, not a video watcher person, you can go on revise that article. So you will get a overview of what I have told. So let's dive into our next concept. This is a very interesting concept. 51%. If you have seen in any movies, if you are talking with your friends, you can see that, right? They are talking about 51% frankly. So we will see exactly what this 51%. So give me a second. What is this 51%? So this is an attack on a blockchain network that is highly impossible actually, but it could be possible to do this attack. So let's see what this attack is all about and how this attack can happen. So the important point to keep in mind is the 51% attack is not an attack designed to tamper an individual block or a data in the block. So it is not a data changing attack. So as we have seen while we are talking about distributed P2P attacks, the attacker cannot tamper with the blocks because there is a majority consensus protocol, right? It is highly impossible to tamper with the block. So it is not tampering attack. So this attack is possible if a person or a group of attackers has more than 51% of total hash rate. So we have seen so much hash rate in the Bitcoin, right? As we have seen in the charts. So if some group of miners or persons have more than 51% total hash rate, so this attack can happen. So let's see what happens. These are some pools that I have shown before, right? There is a pool in pool, BTC.com, Huobi.pool, and there are so many pools that are contributing to network, right? So if 51%, if one pool occupies with more than 51% of hash rate, this attack can be possible. So, or if a malicious pools, if these four pools combined, they can do a 51% attack, but they don't do that 51%, right? So if you do that attack, the price of the Bitcoin goes down. So the price of the Bitcoin goes down. So they don't want to do that, right? So let's say we have some truthful miners who has less than 50% hash rate. So there is a malicious miner having more than 50% hash rate. So what happens here is the truthful miner add blocks to the public chain. So everyone can become miner, right? This malicious miner or a malicious attacker comes and he want to. There is no restriction, right, to join in the network. So he comes and hey, we are also joining the network, and they do a private chain. This malicious miner is adding blocks to his private blockchain. So he also mines the block and he adds the block to the blockchain. So, but he doesn't broadcast that blockchain. So he do it privately. So no one don't know about this blockchain until now. So what now this malicious miner do is he go on buy a let's say he bought a Lamborghini with 100 Bitcoin here, block party, right? Let me show my pointer. Let's say in block party he bought a Lamborghini with 100 Bitcoin. So this transaction is in this public chain, but this transaction is not included in the private chain because he is mining, right? Those group is mining this private chain, right? So what happens after some time? These malicious miners has more hashing power, right? So they generate blocks more efficiently. The correct miner is now adding blocks to his private chain faster pace than the public blockchain. So remember the saying, right? In blockchain, the longest chain is a valid chain, right? So sometimes what happened is now this public chain got 51 size. This private chain has block 52. Now what this malicious miner do is he starts broadcasting the blocks. So what these public real miners, truthful miners will think is, so there is a block which is longer than our blockchain, so it is a valid one, as I have told you in the previous session. So they accept this private chain as a valid blockchain. So what happens all over this blockchain becomes the valid one. So what happens here is the transaction that malicious miner bought a Lamborghini is not included in the private blockchain, right? So he got here comes the problem of double spending. He got his 100 Bitcoin again, which is not included in the private blockchain, but he got a Lamborghini with that. You can see, right? Which leads to double spending. So this is exactly what 51% attack is. This is simply a malicious miner who has more than 51% hash rate will manipulate the chain by mining blocks in faster pace in those private chain, and when that private chain is larger than the original blockchain, they start broadcasting. So when they start broadcasting that chain will become the valid one. So the attack is possible like this. So here comes the double spending problem. So I hope all of you got an idea of what is 51% penalty. So if you have any doubts, please comment. So these are the main disadvantages of the attacker. He uh, he has high electricity costs. His renting space and storing for all the mining hardware is high. Covering your tanks and laundering the money is so a risky thing, right? So they don't want to do that. Risk of getting caught and prosecuted is also one of the disadvantages. In reality, these types of attacks are extremely hard to perform. So this is hard to perform attack, but it can be possible. But if they do, uh, it is so the whole network fails, right? Everyone knows that there is 1% attack, and the value of that native currency will be go down, and the incentive will be no value for them. So they don't want to do that attack. Okay, I hope all of you understand the concepts, right? What we have discussed is we have discussed about how to calculate mining difficulty. We have discussed about how Bitcoin works. We have discussed about nonce range. We have discussed about the famous 51% attack. We will see how transactions work in Bitcoin blockchain in the day 3 session. I hope the time concludes here. So if you have any doubts, please post in the comment box. I will clear your doubts. You can, if you have any doubts, you can rewatch my YouTube video.
Yes, Kaushik. So yes, so see, these presentations will not be shared to any of these mails. See, you need not go through these presentations. Nothing are in these presentations. Everything are within the demo, so you can just go through the video. So anyhow, after this session is done, live session is done, this video will be present in your YouTube channel. So if you are that interested to go through the presentation, right, you can just go through the video rather than going through the presentation. So we will not be sharing any presentations from our side. Already we have shared many links, many reference links in the chat box, so you can just go through those links when they are necessary. And also when you want to go through these presentations, go through the video. And see, this 3-day workshop is going to be completely on YouTube streaming itself, because anyhow, are you facing any difficulties with this? Like some people were asking me regarding this Google Meet and all. Are you facing any difficulties with this particular what we can say streaming live on YouTube directly? Let me know in the chat box. See, it was Naveen was telling me that Google Meet was better than Zoom, and when will Zoom meeting start, and something like that. So there are no difficulties with this. Right, live streaming is better than Zoom and all. So we are going with this live stream. And if it is some not able to zoom the screen, okay. Like if you view it in the full screen mode, right, you can obviously see it as the full screen mode. And moreover, the font size is also quite high in the entire presentation. The font size is also quite comfortable, I think. Even I am trying to watch it from my mobile phone. Even I am able to see each and every text clearly. See, one point I want to clearly mention here is like we can obviously conduct it on Zoom or Google Meet or any other platforms, but remember this one point: interaction is when interaction is main criteria. Here also we are trying to interact as much as possible, because when we were conducting this live on Zoom, and also we were conducting all the sessions on Zoom, and also we used to stream that live on YouTube. But what happened there was questions were posted in both YouTube chat box and also Zoom chat box, which was quite difficult for the mentor to go through actually. So enough, the interaction will be very clear when we use only one platform. We cannot just use only Zoom platform without streaming it live on YouTube. So we will be definitely streaming this live on YouTube, even if we use Zoom or any other platforms. So in that case, it will be difficult for a mentor to go through all the questions posted in the both chat boxes like Zoom and YouTube chat box. So it is better if we use only one platform, and that we chose as Zoom. If it is some paid courses or paid webinars, right, definitely we'll be not going with this Zoom live. Sorry, YouTube live. You actually, I think you know this. Yes, you can easily interact here. See, Hari Krishnan, if you have any queries, you can freely post those in the chat box. So, Kaushik is trying to answer all your queries immediately. So, the only thing is you have to post queries in the chat box. If you don't post any queries and if you are expecting us to interact, then that will not be possible. Yes, okay, fine, right? So you can keep posting the queries regarding today's session on blockchain and Bitcoin fundamentals, like regarding this Bitcoin. Kaushik will answer you. Yes, Kaushik.
Yes. If you have any doubts, please comment in the chat.
And I have sorry for the inconvenience. See, I have already posted this feedback link in the chat box. Do fill that feedback link and also subscribe to our YouTube channel, because in further sessions also you can just get this instant notification. Tomorrow the session again starts exactly at 6:05 p.m. So try to be in the session. Like try to like not join the session, view the session at exactly 6 p.m. Yes, yes, okay, fine. YouTube is better. You can just post your queries. If you have some regarding today's session, you can just post those in the chat box.
So you can uh, post your queries in comment section, not only in live chat. I can also answer in the comment section in the YouTube. So if you are watching this video later on time, you can also ask questions in the comment section. So I think Sushant, we can wind up the session. I think there are no more.
Yes, so we will wait for just one for 2 more minutes. If you have any, if any of
Yes.
the participants have any queries, post those in the chat box, or else we'll just end this session in 2 minutes exactly. So make sure to post the queries in time.
So Anusri Manoj is asking, does Bitcoin promote black money? See, it doesn't promote any black money. So if you want to launder black money, some there are some disadvantages for the Bitcoin also. We are talking about Bitcoin, particularly Bitcoin means it is blockchain, right? So it is important to know how it works, right? So that's why we are talking about Bitcoin. So Bitcoin can be used to launder black money. There are so many issues, but I am not promoting any Bitcoin, right? So do your own research. So there are so many improved techniques, and there are so many consortium blockchains coming. So why I'm introducing Bitcoin is it is the first application created on top of blockchain. So if you understand how Bitcoin works, you will get a whole overview of how blockchain is done. So you can easily learn any blockchain platform again, like Ethereum or Hyperledger or anything. Okay, Morgan says thank you, sir. Just want to say thank you. Preeti says thanks. Okay, thanks. So you can watch. If you have any doubts, you can watch the YouTube video once again.
So I think we have to end this session right now. So I thank all the participants, and I again thank our associate partners for cooperating on conducting this particular 3-day workshop on blockchain and Bitcoin fundamentals. So if you have not gone through this first day one, right, day one session, if you were not present in day one session, you can just go through the day one session that is present in our YouTube channel video section. So once you go through that day one session, then you can just again go through this day two session so that you'll get clear understanding on this particular topic, that is on blockchain and Bitcoin, what we can say fundamentals. So tomorrow Kaushik will come up with one more interesting concept. So make sure to join tomorrow's session also. That is, try to join exactly at 6 p.m. So okay then. Thank you all. Thank you. I sincere thanks to branding partners and also to all the participants that have participated today. Thank you.